Hello everyone and welcome to Azam Shar Weekly. And in this video, I'm going to show you that how you can perform collision detection in RealityKit. And you can use all of the things that you're learning over here when you're building your Vision OS applications, because RealityKit is just such an integral part of Vision OS. So we're going to start with this basic code. You can see it's nothing really much going on. Most of this code you get when you create a brand new RealityKit project anyways. What we want to do is we want to make sure that we are adding something on the screen. All right, so right now inside the Make UI view, you have an AR view and we just return the AR view. So we don't really add anything to it. All right, like none, we don't have any entities, we have no floor, no cubes, no shapes, nothing going on. So the first thing I'm going to do is I'm going to create a floor mesh. And we are going to use the mesh resource.generate plane. A plane is a two-dimensional, so kind of like you can think of it like a paper, or a cardboard that you can just lay flat. You can make it stand up also, but we're just going to make sure that we lay it flat. The width will be 0.5, the depth will be, let's say, 0.5. You can see it's only has like two dimensions, like width and depth. It doesn't have the height. Next, we will create the floor entity. So I'll simply call it floor. We'll use the model entity, and we can provide the mesh over here. So the mesh kind of is the skeleton. So we're going to provide the mesh over here, floor mesh, and some sort of a material that we can use. So I'm going to use a simple material. Let's go ahead and pass in the color blue. Metallic, yeah, sure. Metallic is just going to give us a little bit more shine to it. Whenever the light is going to reflect from it, it's going to have that shine. So that's good. What other things we can do? Well, we can go ahead and also say over here floor.generate collision shapes to true. Whenever you say generate collision shapes, then it becomes part of the collision, all right? And the gravity and all that stuff is going to act on it. So you make sure that you always call generate collision shapes and you pass in true. In order to put the floor or itself, the model entity, we have to create the floor anchor. So I'm going to go ahead and say floor anchor, and we will use the anchor over here, passing in the plane, and horizontal anchor. So this means that this anchor will automatically be added whenever it finds a horizontal plane. Like this can be a carpet, it can be top of your desk, a surface, a flat surface, a horizontal flat surface. Now, one thing to keep in mind over here is we are using anchor entity and we're passing the plane horizontal. Make sure, and that's very important, that you are connected to your actual device, like wired connection or Wi-Fi connection, but this is my actual device. I'm not using any simulator. If you don't use this actual device, then this function that we're calling, this initializer, this can give you problems that, oh, this doesn't exist. So make sure that you're connected to the actual physical device. I cannot emphasize this enough. All right, this is the number one mistake people do. They're like, oh, I have selected the simulator, but it's not working. This line is giving you error. Well, make sure this is selected. All right. Okay, so we got the floor anchor. That's pretty good. The next thing we want to do is to simply add this floor anchor to the scene. But before we do that, we will use the floor anchor and we will add the child, the entity in this case. This means that this anchor, what is anchored with it, or what kind of an entity is added, to the anchor, well, it will be the floor itself, which is a model entity, which is just a plane. Next, we can say arview.scene.add anchor, and we can simply go ahead and add the floor anchor. Great. We should probably run this and see how this looks like. So let's go ahead and do that. All right, so I'm going to go ahead and run the application. My iPad is already connected. So we should be able to see what's going on. All right, here we go. It's going to try to detect the plane, and whenever it detects the plane, you can see that we are putting that, the blue floor that we just constructed. Looks pretty good. The size is 0.5 meter to 0.5 meter. That's why it's a square. All right, that looks pretty decent. So what will be our next step? Going back to our code over here, the next step can be to add a cube. So for that, we will need to create the actual cube. And we can go ahead and create the anchor, we can create the mesh and all that stuff. So let's go ahead and create a cube mesh, which is mesh resource.generate cube with a particular size. 0.3 meters is fine. And since it's a cube, it's going to be applied the same size for all the sides. We'll create the cube using the same exact procedure, which is model entity, passing in the mesh, which will be cube mesh, and passing in the material, which in this case, we don't have a material, so we're just going to go ahead and create a material. Let's make sure that the cube is like orange color or something. That's fine. We will also go ahead and create a cube anchor, which will also be the anchor entity plane horizontal. So whenever the plane is detected, this particular cube anchor is going to be added. After we added the cube anchor, what we want to do is to also make sure that the cube anchor dot add child, and the cube is added as a child. And finally, we will say arview.scene.add anchor, and then we'll say cube anchor. Okay, great. Let's go ahead and build it. Perfect. Now, one of the things that I want to do is I want to put the cube a little bit higher, because eventually we want the cube to fall down on the plane. So I'm just going to go ahead and adjust the cube anchor.position.y equals to 0.5. So that's 0.5 meters. So the cube should be a little bit higher than the actual floor. And we're doing that on purpose. Let's go ahead and run this. Okay. And let's go ahead and take a look at our page over here. It's going to run. Here we go. As soon as the cube is added, you can see over here, cube is a little bit higher. It's orange. There is definitely a space, between the cube and the floor. And I can kind of like go at the bottom and you can see a little bit of space. Okay, so that's doing pretty good. All right. The next thing that we want to do is to enable physics so that the cube can just fall down on the floor itself. So how can we do that? Well, let's check out the cube over here. We have the cube, and we can add a bit of physics to the cube. So cube.physicsBody. This will be a physics component, and we can pass in like different things over here, like the mass itself. The default is fine. The material, the default is fine also. And the mode. Now this is an important one, and we're going to select dynamic over here. Dynamic means that the forces, as the description says, that this particular object, entity that we're creating, which is a cube, the forces can act on it. Kinematic simply means that it's controlled by user, and static means it doesn't really move. So we're going to use dynamic and for our cube. Okay. The floor is right over here, and let's go ahead and copy this and copy paste it over here for the floor, because we do need to set something for the floor. But for the floor, we're not going to say dynamic, or else it's just going to fall down towards eternity. We're going to make it static. So floor is kind of like permanent. It's not going to move. but the cube itself is dynamic, it can move. And as soon as we put this physics body, the forces, the gravitational forces, which is 9.8, it's going to affect on the cube and it's going to just fall down. But luckily, we will have our floor underneath, which is static. It's not going to move. So the cube should fall down on, on the actual floor. Okay. The best way to just run it. Let's see what happens. So I'm going to go ahead and run the application again. A little bit zooming out. I'm trying to see if I can zoom out a little bit. Interesting. So it didn't really fall down. Well, that's the first thing I'm looking at. You can see that the cube is not really falling down. Okay. So what exactly is going on? I mean, the cube was supposed to be falling down. Remember that in the floor, we set it to be generate collision shapes, but we didn't really do that for our cube. So let's go ahead and do that. Okay, generate collision shapes. I think that should be enough, hopefully. Let's go ahead and run it again. If you don't have collision shapes, then it can't really take part in the physics. Okay, we're still waiting for this to build up, and there we go, and oh, that was close. It almost fell out of this particular plane, right? But you could see that it actually falls down really nicely on our blue floor, our plane. Now, one thing that I want to do, so it is colliding with it, and it would be really nice if it collides with the floor. When the cube collides with the floor, then we simply print out some sort of a message in 3D in our world, in our augmented world, saying collision detected or something like that. All right. So that would be really amazing. But before we do that, let's go ahead and thank our sponsors. This video is sponsored by Azam Sharp School, one of the largest catalogs for iOS development videos. You can see that on the Azam Sharp School, I have created 21 courses, 120 hours. I'm also running some workshops, and luckily this time the workshop is on Introduction to RealityKit. It will be on February 24th, 11 a.m. to 2 p.m. It's going to be an amazing workshop. Make sure that you register for that workshop, because RealityKit can be confusing, right? It can be very hard. And in the workshop, I will have activities. You will meet other people. So it's going to be a lot of fun. And I do offer membership pricing, $25 a month or $249. And it gives you access to all the current courses and all the future courses also. Now, there is a deal also going on right now. Here you can see for any course that you want to, since this is my birthday week, I'm running a promotion. If you use the coupon code birthday 2024, then any course 42% off. All right. Now, this only lasts till February 12, 2024, and this can only be applied to the courses. So make sure that you take advantage of that particular deal. All right, but check out the courses over here. MV Pattern, Full Stack iOS Development, Swift Data, RealityKit Fundamentals, Mac OS, Create ML, Navigation. I mean, it's just all the courses you can imagine when you are a iOS developer. All right, so check out azamsharp.school. Check out great pricing, and also definitely check out this workshop. It's going to be amazing. Thank you so much. Now let's go ahead and try to add some sort of a collision into our application. All right. And what we are going to do is we have the physics body on the cube itself. What about if we go over here and say cube.collision and add a collision component also? You can see just like a physics body component, there's also a collision component. All right. Now in the shapes, we have to pass in the shape of the collision or the shape of the object that's taking part in the collision. And we have a cube which has a, well, it has a box shape of 0.3. So we can kind of like pass the same exact thing. So I can go ahead and say generate box of the same exact size. So the collision can be detected with the same exact size. So that's perfectly fine because the cube is also 0.3 meters and the whole thing will be collision detected. The mode over here is default or trigger. The trigger part is that it's only going to be triggering the collision, and the default is that it will be taking part with the other objects also. So I'm going to just set to default, and over here we have default and sensor. Sensor is mainly used like in games, like when you maybe collide with something silently, then you can use a sensor. I mean, both will work, but I think we should use a default, which means that this cube will be, part of the collision. And the size over here, I think we have to define it in a little bit differently. 0.3, 0.3. So this is a SIMD vector. So I'm just simply passing in all the three, in a box, in a cube, three different sides of the particular box over here, or three different sides. Okay. Okay, so we got the collision. That's pretty good. Now, one of the things that we have to find out is when you're performing a collision, there should be some events like the collision has detected or the collision has not detected, or the collision has begun and not or ended. So where do we handle those events, right? Where do we handle those kind of events? Now, there are many different ways that you can try to handle those events. I mean, we can go ahead and implement this over here. Let's say if I try to handle it over here, so I have the AR, let's say over here, I say AR view dot scene dot subscribe. So there's a function over here called subscribe, and we can subscribe to a particular collision event. So I can say over here, collision events dot begin. You can see that we have begin, ended, and updated. Begin means that when the collision has actually begun. So when the cube actually collides with the plane, so that will be the actual begin event. And the handler, we're going to get the actual event itself. Okay, so let's go ahead and build it. Now this subscription is going to send you back or return you something like a cancelable. And if we don't hold this, then nothing will work because the subscription just got lost. So let's see that how we can hold this. And this might be our first take. So we might just go to the AR view container and create, let's say, a collision subscriptions, which is simply an array of cancelable. So cancelable is not available right now because we have to import combine. So I'll simply go ahead and import combine. So I'll have access to the cancelable. There we go. Okay. Probably have to do equals to. So whenever the subscription is returned, what we are going to do is we are going to use collision subscription.append, and we're going to append this. Let's see where we can append this. Right here probably. Or are we appending the whole thing? Let me see over here. Probably the whole thing. I think we have to add the whole thing, right? There we go. Now we have a problem over here. It's saying that cannot use mutating member, self as immutable. So collision subscription, we can't really mutate it because we are inside a struct. We can, if you want, we can try to decorate it with a private var or like a state, and that at least builds this application. Just like the begin, we can also make sure that we also do ended. So ended should be fired whenever the collision is done. So probably it will be fired really close to when the cube is resting on the plane itself. And over here, I'm just going to say begin. And over here, I'm just going to say ended. Okay. Now keep in mind that we have only added the collision to the cube itself. The floor doesn't really have any collision. So will that take into account, or will that affect our output? Let's go ahead and run it. And what we're looking at is when it collides, it should say begin or ended. All right, so let me go ahead and run this. We know that the cube is going to fall. Now you can already see there's a big problem going on. Well, you will see actually in a minute. Okay, so it's landed. You can see first of all, it's not really firing. That's the first thing. The other thing is that we're modifying the state during the update, right? So that is never a good idea. So that's why I wanted to show you that this might be your first take, that to add the collision subscription right over here inside the AR view container, but it's not really recommended, as you can see. So instead of doing this, let's go ahead and comment this out. And if you watch one of the last videos, we talked about creating the coordinator. So this is the time to create a coordinator so the coordinator can handle these collisions. So let me go ahead and start creating a coordinator. Class, coordinator, NS object, AR session delegate. Although we are conforming to AR session delegate, I don't think we actually end up using any of these functions in the AR session delegate. So let's go ahead and not use that for now. And over here, we are going to do the same thing. We're going to get access to the collision shapes, and we're going to get access to the view. Okay. Next, we will create a function called setup collisions. Not collections, setup collisions. Now there are many different ways of setting up the collision. This is just one of them. This is not the only way. Okay. The first thing we need is we need to go ahead and get the actual view. Great. And now I can scroll down at the bottom and kind of like just pick up these two things and just put it over here. Now, one thing that I don't like about this approach is I have to manually call setup collisions. Now, you might be wondering, why can't we just call this from the initializer? It's too early to call it from the initializer because the view will be nothing. It will be empty, or not empty, but it will be null. So that's why you cannot really call it from there. Okay. Okay, so we got this. This looks good. Now we just have to start using this particular coordinator. I'll say make coordinator. That's one of the other functions of UI view representable. And this is where we can go ahead and create the coordinator. Let's go ahead and create the coordinator. Perfect. And we also have to set up a couple of different things for the coordinator, like the view, and we will have to manually call the setup collision function. Let's go over here. We'll say context.coordinator.view equals to view, or AR view in this case. After we set up this AR view, then we can call coordinator.setupCollision. Now, I know that this is not the perfect way. Other way and a much better way is that you create these custom entities and they will already set up the collisions. But we're just learning, so this is perfectly fine just to get started. Okay. Okay, so looks good. Let's go ahead and run this and try to see that if we get collisions or not. Now I'm going to run this application. What we're mostly interested in is if the collisions are fired or not. Let's go ahead and zoom out a little bit. There we go. And there we go. You can see the collision begin, begin, ended, ended, begin, begin, ended, ended. Why begin and ended? Well, I don't know if you noticed, but the box was actually jumping, right? It was bouncing. So it was begin, ended. Ended means that it was not connected anymore, or basically it was connected or it was touching, and then begin and then ended. Okay. So when the box is actually resting, which it is right now, the collision has ended at that point. So what should we do at this point? Well, whenever we get the collision, it would be fun to just put something in a text and say that, okay, collision has happened. Something like that. I think that will be a little bit fun thing to do. All right, so let's see how we can do that. The first thing I'm going to do is in the begin part, I'll create an anchor, which will be an anchor entity. And we can pass in the plane like horizontal, that's fine. We can also set up some sort of a position for the anchor. So let's go ahead and say anchor like 0.3. It's a little bit above the floor. And then we can also say anchor name so that we can refer it later on. I'll just say text anchor. And now we can create a text. Just like you can create a cube, just like you can create a sphere, you can also use a model entity to create a text. And this is available through the mesh resource dot generate text. So what are we typing over here? I'm just going to say collision detected. The depth of the text, we can say 0.03. The font part is important because you want your, your actual text to be nice size. So don't put like 18 or something over here. You're going to put like 0.1 because it's in meters. The frame over here, I don't think we're going to pass in anything, so we're just going to say 0. I don't know if we need any of these things. I think we need a couple of different things, but not all of them. So just go ahead and wrap this up. We don't really need any of that stuff. The material itself, we can use simple material. So I'll say simple material. Color, we can say red, metallic, yeah, sure. Once we have that, we will use the anchor. We will add the child, which is the text, and then view.scene.add anchor, and then we'll add that anchor. Now keep in mind that when we do that, and actually you will see in a moment, let me go ahead and run the application so you'll see the effect. Okay, let's go ahead and run it. Okay, we're trying to make sure that it zoom out a little bit. Sometimes it can take a little bit of time. Well, that's taking a lot of time. Oops. Not sure why it's so big, but here we go. It says collision detected. Oh, it says collection detected, but at least it's something, right? All right. Did I say collection detected? Keep saying collection for some reason. Collision detected. Okay. Now, one of the things that you have to keep in mind is since you are adding an anchor and adding a text, and this is firing whenever the collision begin can fire multiple times, right? So you don't really want to add the text multiple times. So we can check over here. Or we can say view.scene.anchors.contains and element, where element, which is anchor.name, if it's equals to text anchor, then we can say exists. And if not exists, then we will do all of this stuff. Okay, so that's going to help us a little bit so that we don't add the text anchor again and again. Let's go ahead and run the application again. Not sure why the box was so big. I thought it was supposed to be a little bit smaller than that. We're going to wait a little bit. Sometimes it can take a while for some reason. There we go. And it says collision detected. Beautiful. Absolutely great, right? This is exactly what we wanted to do. Perfect. Now, this is just a starting point for your application. I mean, you can have collision between two cubes or a cube and a sphere and other elements also. I mean, this will be a lot of fun, but this will be a great starting point for you. All right. And once again, if you do want to learn more, then check out the RealityKit workshop. This is a great workshop. The link will be right there in the description. And this workshop is going to teach you everything you need to know about RealityKit so you can at least get started. This is a great workshop, and this is a very practical workshop. All the last workshop that I've done, they're all sold out. So make sure that you take advantage of this situation and register for Introduction to RealityKit workshop. All right, thank you so much again, and I hope you have enjoyed this tutorial. Thank you.